Question 5, we're given that we've got a camera at point C, which is 3 meters from the edge of a straight section of road, as we can see in the diagram, and the camera detects a car traveling along the road at time equals 0. It then rotates, always pointing at the car until the car passes point O, which is the point on the edge of the road closest to the camera. And some information we're given is the car is traveling at a speed of 24 meters a second. And if we let the position of the car be x and the angle OCX equal to theta, so we'll add that in there, we're asked to find d theta by dt, which is the rate of the rotation of the camera in radians per second at the instant the car passes the point O. So if we let this distance O to x, we'll just call it little x for now. We know that the car's traveling along the road at 24 meters a second. So we know that dx by dt is equal to 24 meters a second. And we want to find d theta by dt. So we can do that just by using the chain rule. So we want to find this, d theta by dt. Using the chain rule, we know that it's going to be equal to how theta changes with respect to x times how x changes with respect to time. So we want to find this one here, some expression for that, because we don't know what that is yet. We know what dx by dt is, that's 24. So can we find some equation to relate theta and x? Well, we know this triangle in the sketch here is actually a right angle triangle, because we're told that from the point O to the point C, or from the camera to point O, that's the shortest distance from the camera to the road. So that's the perpendicular distance, is the shortest distance. So we can add in a right angle there. And then we've got an opposite side and an adjacent side. So we know that tan of theta is equal to x over 3. So therefore 3 tan theta is equal to x. So now if I differentiate both sides of this with respect to theta, we can get some expression for d theta by dx hopefully. So if we have x is equal to 3 tan theta, differentiating both sides with respect to theta, we're going to get dx by d theta, that's differentiating x with respect to theta, is equal to 3, well, differentiating tan theta, we're going to get secant squared theta, and therefore we're going to have d theta by dx is equal to 1 over 3 secant squared theta, which is equal to 1 over 3 cos squared theta. Okay, so now I've got an expression for d theta by dx. We've got our expression for dx by dt. So now we can just plug everything in and we can find d theta by dt. So we know d theta by dt is equal to 1 over 3 cos squared theta times dx by dt is 24, and that is equal to 8 cos squared theta. So so d theta by dt, which is the rate of rotation of the camera, we want it at the instant the car passes the point O. So the camera detects a car traveling along the road at time equals 0, then rotates pointing at the car till the car passes point O. So all we need to do is that angle there, when the car passes at point O, well, theta is going to equal 0. So at theta equal to 0, we're going to get d theta by dt is equal to 8 cos squared of 0, and obviously cos of 0 is just 1, So that is just 8 times 1, which is 8. So therefore, we have d theta by dt is equal to 8 radians per second.